Alrighty, ladies and gentlemen, today we're going to learn about the Pythagorean theorem. So a few things when we talk about Pythagorean theorem, we are talking about right triangles, so we kind of need to know we need to know everything about right triangles. So right triangles have one right angle, and across from that right angle is your longest side of a right triangle, which is called the hypotenuse. Now, if you think way back to our unit on triangles, this kind of makes sense because we learned that your biggest angle, the longest side in a triangle is opposite the biggest angle. And in a right triangle, your 90-degree angle will be the biggest angle. The other two sides are called legs. Now, sometimes when you see triangles being labeled, they might also say, hey, your legs are A and B, they're hypotenuse of C. Now, first things first, we're going to prove our Pythagorean theorem and get what the Pythagorean theorem is. So look here at this proof of the Pythagorean theorem. A lot of proofs can be visual, not always algebraic, and they don't always have to be two column proofs either that we learned about in our triangles unit as well. So I've got this right triangle. This is a leg and this is a leg. And we have this leg squared. So like from here to here is the same as from here to here. And we have this other leg squared. Now we're going to kind of take each leg and put them into here and see what we notice. So I'm going to take the yellow, bring it down. I'm going to take the green and bring it down. I'll take the red and bring it down. Purple and whatever this like really light blue is and bring it down. So if you notice, we took both squares of each leg, and when we put them together, they fit into the square of the hypotenuse. And so that is what the Pythagorean theorem states. It states that your leg squared plus your leg squared will be equal to the hypotenuse squared. And visually, that's exactly what we did. I had the leg squared and the other leg squared. We put them together, and together it equaled the hypotenuse squared. Alrighty, so Pythagorean theorem is just your leg squared plus your leg squared, and that equals your hypotenuse squared. You might remember this more so from middle school as being a squared plus b squared is equal to c squared. I don't always just like random formulas. I kind of like to know where they come from. I much prefer talking about Pythagorean theorem in this way than I do with the a squared plus b squared equals c squared. I think about it as being your leg squared plus your leg squared equals a hypotenuse squared. So here we go. We're going to do a couple examples. Now, here, if you notice, we are given a hypotenuse and we're given a leg, and we are looking for the other leg. So if I go back to my leg squared plus leg squared equals a hypotenuse squared, my leg squared plus my leg squared equals my hypotenuse squared. So 17 squared plus x squared is equal to 19 squared. A couple different ways to actually solve this. We need to get x squared by itself. So I need to scooch the 17 squared over. So I can subtract 17x from both sides, or 17 squared from both sides. And then I'm left with x squared is equal to, and I'm going to go ahead and use my calculator and pop in 19 squared minus 17 squared. Now, if you absolutely want to figure out what 19 squared is and what 17 squared is and then subtract them, you are more than welcome to do that. It works just as easily to do it this way. And I get 72. So x squared is equal to 72. Now to get x by itself, we're going to need to take the square root of 72. Now, you can use Desmos again and get a decimal equivalent, or we did learn about simplifying square roots last week for a reason, so we're going to actually put this in simplest radical form. You'll know what to do based on your directions. So if I think about 72, 72 is just 2 times 36, but we can double check that because I'm having a moment with my arithmetic here. So if I do 72 divided by 2, I do get 36. So we have 2 and 36, and then 6 is just 6 times 6, or you could use 9 times 4. You'll still get to the same right answer that I'm going to get to. I have a set of doubles, so I'm going to write that once because the square root of 6 times 6 is just 6, and I'm going to leave the 2 underneath there. So it's 6 square roots of 2. My second example, I'm given 2 legs, and I'm looking for my hypotenuse. So my leg squared plus my leg squared is equal to the hypotenuse squared. So I can go back into Desmos. And put in 5 squared plus 13 squared, and that gives me 194. Oops, keep hitting my little button here. 194 then is equal to x squared. And to get x by itself, I need to take the square root of both sides. So I'm going to go ahead and just pop this one into the calculator. So here's my square root symbol, and I can do 194. And I get 13.92. I'm going to just round that to the nearest tenth, so it's going to be 13.9. You might remember from Algebra 1 that we always took the plus and the minus version of a square root. Since we're dealing with lengths in geometry, our distances are always going to be positive, so I'm not worried about the negative version, and that's why we're sticking with the positive. Next example. So here I'm given a hypotenuse and a leg. So here I'm going to do my leg squared plus my leg squared is equal to my hypotenuse squared. So I need to subtract 10 squared to both sides and get x squared is equal to, go back to Desmos. And I've got, 20 squared minus 10 squared, which is 300. I'm going to kind of save myself a step here, and we are going to take the square root of 300 right here, and we get 17.3. So x squared is equal to 300. I'll take the square root of both sides, and we did get 17.3. Last example, I've given 2 legs. I'm looking for my hypotenuse. So leg squared plus leg squared is equal to the hypotenuse squared. We can do 14, 5 squared plus 14 squared. That gives me 221. And then we take that square root. I get 14.8. So we can actually, let's try and simplify this one a little bit. So 221. If we divide that by 4, nope. 3, nope. 5, definitely. Yep, nope. Maybe this was a bad one to do, obviously. Okay, so we're just going to leave it with the square root of 221. It looks like it might be as simple as it goes. With 14.86, or I'm going to round that to 14.9. Alrighty, so that is what you're doing on tomorrow's practice in a nutshell. Just practicing your leg squared plus leg squared and and making sure that that equals that hypotenuse squared. If you have any questions, message me.